Yes, well, hi everyone. My name is Hanne, and I'm a biomechanist, and I'm working at Team Denmark, which is, can you hear me?
Yeah, just make the...
Okay.
You're the tall girl, right?
Yes, I am. I'm working at Team Denmark, and that's the Danish elite sports organization. And today I'll be talking to you a bit about my work with biomechanics. Mostly about how we try to use it and implement it, and not so much about the exactly results of our testing. And just shortly to briefly describe what Team Denmark is, our purpose is to support our world-class athletes. Right now, we had a discussion this morning. We think it is about 25 federations that we support with a number of athletes in each federation. So, and one of them being athletics. Maybe can you see it? It's not possible for that line to go down.
Just try to.
Okay. Okay.
Sorry.
Yeah. So we support the athletes in various ways. One of the ways is that we have a group of specialists. I'm being one of them. We are 25 specialists altogether in Team Denmark. And we are divided into these groups. We have engineering, psychology, nutrition, sports medicine, performance analysis, biomechanics, and physiology. And I obviously am in the biomechanics box. And I work with the athletes on my own sometimes, but mostly I cooperate with some of my colleagues. Ah, that helped. Yeah. And I have two of my colleagues here today. Michael, maybe you can raise your hand. He's a physiotherapist, so he's in the sports medicine group, and also Richard, who is a physiologist. And these are the two groups that I collaborate with the most. So I tried to make this list of the test and analysis that we're doing in these three groups. Just to run through them quickly, we do strength testing, we do jump testing. At the moment, Richard is trying to implement the Noraxon equipment in our jump testing protocols. We're having some issues because we don't always test at our facilities in Copenhagen. We often go out to the federations. So we move our equipment around quite a lot, and the force plate, as it is right now, has a bit of trouble with being moved around, so the measurements is not that stable, but Richard is on that part right now. Then we do some cardio testing, and we do speed testing, and then I do some technical analysis, and I thought I'd just show you an example. At the moment I work, you cannot see anything here. Maybe you can see it down on the screen here. I work quite a bit with the swimmers, where I try to improve their starting technique and their swimming technique in general. And the way I do that is purely by video analysis. At the pool that our national team swimmers is training, we have this German system installed less than a year ago from Contemplas. Maybe some of you know it. So it's an 8-camera system, where we have 5 cameras underwater, this being one of them, and then 3 above. And then the way we do the feedback here, so this is Jon, our national coach. So we have this screen just next to the pool. So when the swimmers, they do their swimming, they come up, grab their towel, and then we do the feedback straight away. Nice try though. Okay. Yeah, and so we also do some baseline testing, and that's actually Michael's part. Yeah, that's good. Yes. And at the moment we haven't integrated the Noraxon, but that's on Michael's to-do list to try and implement that in the near future. Then we have several kinds of injury prevention, and then the last bullet, the explorative biomechanical testing, that's when I'll be talking mostly about today, I have 3 different examples that I want to show you. So it has happened a few times that one of my colleagues has come to me and said, I have this athlete, he or she has a problem with this muscle. Can you help me try and measure the muscle activity to see how it reacts to different exercises? And we've done this with some track and field athletes, some badminton players, and some orienteering runners. So I thought I'd just show you one of the badminton cases. So here is Line. She's one of our best female single players. And Michael came to me one day and said, I have Line here, she has trouble with jumper's knees, and she always also has some decreased strength in her right calf muscle. Can we do some explorative testing, biomechanical testing on her? And of course I said yes. So we took her down to the badminton court, and she did some specific badminton exercises. We had EMG on the gastrocnemius and on the soleus on both sides. And then we also took her in the gym afterwards, where she did lots of different exercises. And to be able to compare the activation between all of these exercises, we also made her do a 1RM for both the gastrocnemius and for the soleus on both sides. And so what came out of it, this is like a bit shortened, but a slide like this, where you can see, so in the top I have all the 1RM, and that's defined as 100% activity. And then I have all the different exercises below, which is related to that 1RM. So this is sort of a tool for Michael to use when he's figuring out which training exercises that he should use for Line specific, not for other badminton players, but only for her. And Michael, I think when you saw it, I think maybe there were a few surprises to you, but I think most of it maybe weren't that surprising to you, because a lot of my work is also just to put numbers on what my colleagues already knows from their experience. Yes, so next example is a project that we've actually paused even before it got started, but I just wanted to tell you about the idea anyways. It's about screening of muscle pre-activation to prevent ACL injuries. And the thing is, we know that increased muscle pre-activation in the semitendinosus muscle during side cutting decreases the risk of ACL injuries. And right now we can measure this pre-activation in our labs, but we only have a few labs in Denmark that can measure this. And it's quite time consuming to get our athletes in these labs, and it's also expensive. We don't have one at our facilities in Copenhagen. And what we do in the lab, if we do that test, then we put electrodes on the semitendinosus, and we make the players, it's mostly handball and football players. We make them run on a force plate, do a side cut on a force plate, and we can measure the pre-activity of the muscles. So my idea was to replace the force plate with the Noraxon insoles. Because if we could do that, we could take the test everywhere. But unfortunately, the insoles right now can only measure relative load or relative force and not absolute force. So that project is paused for the moment, but we really hope that someday we will be able to do it, because that would be a very valuable test for us. Yes, and then the last example, it's from kayaking. I work with them as well. And the challenge here is that in team boats, so in boats where you have either 2 or 4 athletes, the synchronization obviously is very, very important for the performance. But right now, at least in Denmark, I know Germany has this huge setup when we go to competitions, and we have almost nothing. But the tools that the coaches have in Denmark now is just what they can visually see, or maybe from a video recording in regards of synchronization. And that's quite okay to see the pedal, but a lot of the force that is transduced into the water also comes from the legs when they push on the footrest. And that obviously is a bit hard to see in a video. So we were trying to find out how can we measure that timing and that force production from the legs. So the idea was, this is a footrest, so this is what the athlete is pushing against down in the boat. So I did this, and then I took the Noraxon insoles and I taped them to the footrest here. And then I only did this test last week, and it was only like a pilot in a single boat, just to see if I could get data out. And then I persuaded our national coach, Kim, to paddle for me, even though it was very windy that day. He's a former Olympic athlete. I met him on the office the other day, and I was looking at this video. I was making the presentation, and he said, "You cannot show that video to anyone." And I said, "I'll be showing it to 100 people next day." He was a bit worried. So you cannot tell him if you ever meet him. Okay, but it's a little bit hard to see here. But on the left, so we have the two insoles, two different colors, purple and red. And then you see him in the middle, of course, and then the pressure from the insoles on the right. So this was a success to me because it shows that I can get data out in a nice way. It's not that obvious up here, but maybe you can see it on the screen, and it's quite precise when the timing is going on, when the peak is, and when he's releasing the force again. So the plan now is to find a day next week where there's no wind and no rain, and then we'll go out and try and put 2 pairs of insoles in the boat and do the same measure and look for synchronization between the person in front and the person in back. Yes. And then this slide, I just put it in today because I thought it was just a nice example to show how reliant I am of my good colleagues. I got a call from Anders, who is one of our sports psychologists, and he said to me that he had been out. I don't know, Richard, what is this called in English? Dressur. Equestrian, yes. He has been out with one of the riders here, and they were talking about how important it is that the horse can feel the pressure through the saddle from the rider. And he said, "Hanne, those soles you're talking about all the time, can you glue them to the saddle and then put the rider on top of it and then make some meaningful measures?" So I said, of course we'll try that. So maybe that will be the next project for the Noraxon stuff in Team Denmark, equestrian riding. Yes, so I think that's it for me. Thank you very much.